recently. And of course, we also take a lot of pictures from the Space Shuttle, International Space Station as well. Let's turn our attention now to the second commercial space remote sensing system ever in operation, the first after the American Landsat system, and this is the French SPOT satellite. The French developed their competing commercial space system. It received approval in 1978 with the first launch in 1986. And the idea was to have, if you will, a comparable or competitor system to the Landsat, but designed more to European scales of land use and land holdings, which are much smaller than here in the United States. So the original SPOT system had a 10-meter panchromatic or black and white and 20-meter multispectral spatial resolution system. If you go down to that level of detail, though, you ended up with a smaller swath width of only 60 kilometers, 40 miles or so, very small swath width. It had two independent systems, so it gave a stereo viewing ability. And to date, the SPOT system has acquired almost 6 million images over the surface of the Earth. The system has continued to improve significantly over time. Now we have 2.5-meter spatial resolution data from the SPOT 5 satellite, which has been in operation since 2002. SPOT is a commercial system, but it is also partly owned by the French government. And they have a great deal of data about who uses their data for what purposes. And so it's very interesting to look at the SPOT version of what their users are using the systems for. We can see here that, again, mapping, cartography is the largest remote sensing market by far. It's amazing to think, but much of the world is still very poorly mapped. Very little of Africa. Much of the developing world is very poorly mapped at perhaps a 1 to 50,000 or 1 to 25,000 scale. So basic cartography and mapping is still the largest market in space remote sensing. Vegetation studies, forestry, agriculture, etc. Would be next. Geology third, and then sort of everything else lumped together in between. The French's SPOT system is developed by CNES, the French Space Agency, launched by the European Space Agency launchers. And as I mentioned, it is a commercial operation, but it is also partly subsidized by the French government, which is a part owner in the system. Let's take a look at what the SPOT satellite system looks like. Here's one of the earlier spots on the left before launch. So you have some people there working on the system to give a sense of the size and scale of this satellite system. Up here at the top are the two imaging devices, the two exactly similar paired imaging devices. And on the right, you can see a little diagram of the development of the system. SPOT 1 launched in early '86 and up to SPOT 5, which is in operation right now, launched in 2002. The SPOT systems are in that polar sun-synchronous orbit, 822 kilometers, a 98-degree inclination, 100-minute period, so they circle the Earth every 101 minutes. And this gives it a 26-day repeat cycle. So it goes over the same place on the Earth every 26 days. Now that's not a good repeat cycle. That's not really enough, because when you factor in cloud cover, we want to be able to acquire more passes than that, more than once every 26 days. It's a trade-off. They wanted the higher spatial resolution. In order to get that, they had smaller swath width. That means you can't see the same place very often. But the French had a very good, interesting answer to this problem. What they did is they developed their satellites with a steerable mirror. So a mirror, as you see on the right, could tilt, and that allows the satellite to look left and right outside of its what we call nadir viewing position. So this allows it to have an off-nadir imaging capability. And in fact, what this does is this reduces the spot image revisit rate from 26 days to once every 4 or 5 or 6 days. So you can see it can be flying over one place, and it could turn its mirror and scan an image off to the right or left. Very innovative, very interesting, very new technology development in the space remote sensing world. And this also gives it some very interesting capabilities that we'll mention in just a second. I want to show you a picture of the SPOT satellite data. This again is a picture taken on 9/11, and you can see very clearly this is a false color composite, and you can see very clearly not only the smoke plume coming out of the World Trade Center site, but if you look very carefully, you can see the two red hot areas of the fire right here in this location here. You can see individual boats and ships out in the New York City harbor. This is Liberty Island, where the Statue of Liberty is, that little black dot. This is Ellis Island here, the Immigration Center. This is a good example of what the SPOT satellite imagery can provide us. Because the SPOT has this tilting mirror assembly and is able to look to the right and left, it gives SPOT a very interesting capability for developing stereoscopic images. What this means is the SPOT system can look to the left and acquire a slightly off-nadir image of one area, do a couple of passes, image that same area again from the right, and these two off-nadir images of the same location, since we know the geometry of how high the satellite is, how much the image was tilted, this gives us the information to create a three-dimensional model of the surface. And so we can see on this next slide, on the right is a SPOT image draped over what we call a digital elevation model, or a DEM. This is the Grenoble area of the French Alps, where the French held the Winter Olympics a few years ago. This is not a real picture. Well, I guess it's a real picture. What it is a SPOT satellite image in true color overlaid onto a digital elevation model that was created by two off-nadir pointing SPOT data sets. So very interesting capability, very useful capability, again, for creating that third dimension and for creating data that's useful in geographic information systems, or GIS, which is where most of this type of data is now being incorporated. So SPOT has some very interesting capabilities that were quite revolutionary in its day when it was first developed. We require very large telecommunications and receiving capabilities for these types of data. Very high data rates, very large amounts of data coming down when you think about 10 meter, 2.5 meter pixels. This is a picture of one of the SPOT receiving stations, a very large dish here on the left. And on the right, you see a map of all the various different receiving stations that we have around the world that can actually acquire the data in real time as the satellite is passing over that location. SPOT 4 was launched in 1998 and had a variety of new capabilities. One of the most important was the 1 kilometer pixel vegetation sensor. This is very similar to the AVHRR sensor of the NOAA satellites. SPOT 5 was launched in 2002, and it has 2.5 meter spatial resolution in the panchromatic band and 5 meters spatial resolution in the multispectral band. So a huge increase in spatial resolution since the original system in 1986. And you can see here just a couple of images of the kind of detail that we can get with this kind of spatial resolution increase. Very, very high resolution data. The vegetation scanner, as it's called, on the SPOT system, as I mentioned before, is very similar to AVHRR, 1 kilometer pixels, very wide swath width. But the interesting thing about the SPOT system is that it is co-registered with the higher resolution SPOT scanners operating on board the same satellite. And also, it operates in exactly the same spectral bands as the high-resolution SPOT data. So what you're getting is 2 different sensors at different resolutions, but that are co-registered, and if you will, the high-resolution pixels are nested within the low-resolution vegetation pixels, and that allows us to have comparability between the 2 different data sets. Here we see a picture of the vegetation imager itself in the top, and below and at the right you see 2 of these beautiful images. One of the Indian subcontinent with the Himalayas at the top. Beautiful, beautiful images, and extremely useful because of this co-registration together with the higher resolution SPOT sensors on the same satellites. The European Space Agency is also very involved in space remote sensing beyond the activities of the French and CNES and SPOT. The European Space Agency launched their first major space remote sensing satellite in 2002 called Envisat. And this is a huge satellite, monster. The joke name for it could be Battlestar Galactica, because this thing is enormous. 8 metric tons at launch, 10 meters by 25 meters when fully deployed. A total of 10 instruments, 2.2 billion euro cost, an enormous satellite. And I know many of my French colleagues were awfully nervous when this thing was about to be launched, because if they had a launch failure, they lost basically all the stuff that they were going to have for a very long time. But fortunately for them and for all of us, it had a perfect launch and was launched in February of 2002. One of the unique aspects of Envisat is that it is both a passive and an active system. It has the traditional passive electro-optical devices like Landsat or SPOT, but it also has a very large space imaging radar on board as well. So it's slightly unusual in that it carries both active and passive systems as well. Huge satellite, again, over 8,000 kilograms, a launch mass, has a very useful imaging radar as well as many different other kinds of sensors as well.